All right, today we're zooming right in on the human heart. For years, we've had one main way of checking its health. But what if there's a better way? A more powerful, more sensitive tool that can actually see trouble coming long before the engine even starts to sputter. Let's get into the incredible world of strain echocardiography. So let's start with the big question. When you think about it, how do we actually measure the performance of this amazing muscle, beat by beat? It seems like a simple question, right? But for a long, long time, we've only really been looking at one part of the story. For ages, the answer, the go-to number, was something called ejection fraction, or just EF. If you've ever known someone who's had a heart ultrasound, an echo, you've probably heard this term. It was the king, the cornerstone for judging heart function for decades. Okay, so this is where it gets really interesting. On the left, you have ejection fraction. It basically tells you how much blood gets pumped out with each beat. It's a measure of pumping power. But, and this is a huge but, it's often a late-stage indicator. Your EF can look totally normal even when the heart muscle itself is already getting weaker. Now, look at the right side, myocardial strain. Instead of just looking at the blood, strain measures how well the heart muscle squeezes, and that's the advantage. It's so much more sensitive. It can spot tiny early signs of trouble way before the pump even looks like it's failing. So that old way of looking at the heart, it was giving us an imperfect picture. Let's dig into exactly why it just wasn't telling the whole story. The technology that makes all this possible is called speckle tracking echocardiography. Yeah, I know, it's a mouthful. Let's just call it STE. The concept, though, is pretty brilliant. The ultrasound software tracks these tiny natural patterns in the heart muscle. They call them speckles. And just by following how those little dots move, it can precisely measure how the muscle is squeezing or straining with every single beat. And honestly, this quote right here is the perfect way to get it. Think about it. Ejection fraction is just the speedometer. It tells you the car is going 60, but it doesn't tell you the engine is about to throw a rod. Strain is like listening to the engine. It's the check engine light, that little rattle, the subtle vibration. It's the warning that lets you fix the problem before you're stranded on the side of the highway. So now that we get the what, let's talk about the how. We're going to get into the nitty-gritty of measuring the muscle and what these new numbers actually mean. All right, the main number we're talking about is called global longitudinal strain, or GLS. It's basically an average of how much the heart's main pump, the left ventricle, shortens from top to bottom. Now, here's the one thing you really got to remember, because it feels a bit backwards. With GLS, a more negative number is actually a good thing. Yep, more negative means a stronger, healthier squeeze. So what's a good number look like? Well, a normal healthy GLS is anything more negative than minus 18%. You see that? You're looking at a healthy, strong heart muscle doing its job right. Then you've got this little gray area, the borderline range. That's from minus 16 to minus 18%. This isn't a full-on alarm bell, but it's definitely a, let's keep a close eye on this kind of number. Could be an early sign that something's up. And finally, if a GLS number is less negative than minus 16%, that's considered abnormal. It's a pretty clear indicator that the heart muscle isn't working as well as it's supposed to. But this amazing tech had a huge problem when it first came out. Imagine this. You measure a patient's strain on one company's machine, and then you do it again on a machine from a different company, and you get two wildly different numbers. This was a huge issue. How could doctors possibly trust a measurement if it changed depending on the brand of the machine? And this is where the story gets really cool, because the entire medical and tech community came together to fix it. Back in 2010, the big imaging societies in America and Europe got together with the tech vendors themselves. By 2015, they had agreed on the rules. Fast forward to today, and thanks to all that work, the measurements are reliable. They're reproducible. It's finally a tool that doctors can trust no matter what machine they're using. Okay, so the tool is reliable, it's trusted. Now for the most important part. How is this actually being put to work to change people's lives? This table gives you a fantastic snapshot of where GLS is a total game changer. See that clinical value column with the 3 pluses? That means it's a top-tier, incredibly valuable tool in these areas. We're talking about everything from spotting heart damage from chemo early, to diagnosing heart failure, to figuring out the perfect time for heart valve surgery. Let's really dive into one of these because it's such a powerful story: cardio-oncology. The thing is, many life-saving cancer treatments can be really tough on the heart. Strain gives doctors a whole new way to protect their patients through that journey. So here's the new game plan. It's so proactive. Step 1. Before chemotherapy even starts, a patient gets a baseline strain echo. We see what their healthy heart looks like. Step 2. They're monitored during treatment. Step 3. Doctors look for a drop in that GLS number, even when the old ejection fraction number still looks totally fine. And step 4, this is the whole point. If they see a big enough drop, they can start treatments to protect the heart right away, preventing lasting damage. And what's that trigger point? What drop are they looking for? Well, the guidelines say a relative decrease of about 12 to 15% is the signal. That's the magic number that tells doctors, okay, it's time to step in and protect this heart long before the patient would ever feel a thing. Another amazing thing is that strain can uncover these unique fingerprints for specific diseases. For example, there's a rare condition called cardiac amyloidosis. With strain, it shows this really distinct pattern. They call it apical sparing, where the tip of the heart squeezes just fine, but the bottom part, the base, is super weak. Seeing that pattern can be a massive clue for doctors trying to make a diagnosis. And get this for a hard-hitting stat. Think about a patient with a really bad aortic valve, but they feel fine, no symptoms at all. If their GLS is worse than minus 14.7%, their risk of death goes up by 2.5 times. That is a powerful, powerful piece of information when you're trying to decide on something as big as open heart surgery. So, this is all incredible stuff that's happening right now. But where is this technology going next? Let's take a quick look into the future. And believe me, this field is moving fast. Soon, we'll be talking about 3D strain, getting a complete picture of the heart in a single beat. There's something called myocardial work, which combines strain with blood pressure to measure the heart's true energy efficiency. And of course, AI is jumping in, automating everything and helping predict outcomes faster and more accurately than ever before. Which really leaves us with this one powerful thought. When you step back, strain imaging isn't just a new test. It's a fundamental shift. A shift from measuring failure to detecting weakness, from reacting to damage to actually preventing it. So, what if we could reliably predict heart failure before a person ever feels a single symptom? With tools like this, that future feels closer than ever.